there is one problem in distance vector routing algorithm, and the problem is name is the count to infinity. So this problem says that good news travel fast, good news travel fast, and bad news travel very slow. Here good news means decrease in cost and bad news means increase in cost. So basically like you might be thinking that if it is a good news and it is traveling fast, then it's a good thing, right? And if it is a bad news and if it is traveling slow, then it's also a good thing. Why it is a problem? But we want both of these news, either it is a good news or bad news, we want both of these news to travel fast. We don't want any of the news to travel slow. Okay, so why we want that, you will get to know it. So if it is either good news or bad news, we want it to travel fast only. So the problem is basically this: bad news travel slow. Just to make the statement complete, authors write that good news travel fast and bad news travel slow. That is okay, but this is the main problem. I mean, bad news travel very slow, and bad news means increase in cost. So let me show you with the example. What do I mean? Suppose that you have three nodes like this. This is A, this is B, this is C. And now suppose B and C are connected with a edge cost just by 1. Now initially A is not connected to B, okay? And now what happens? Suddenly that suppose that this link get connected, which means it is a good news, because initially the cost from B to A was infinity. Now see, initially the cost was infinity. I'm not writing the whole distance vector, which means I'm not writing this the distance vector from B to A, which is infinity, B to B 0, B to C is 1. I'm not writing the whole distance vector of B. I'm only writing the first entry, which is infinity. Okay, I'm only writing the entry to A. Similarly, I'm writing the entry to A from C. From C also it is infinity, right? But once this link get connected, which means once this happen, then A will exchange its distance vector to B. So A will say that I'm just one hop away. So B will just update the distance to A to 1. And till now C have not updated it. Why? Because it will update in the next round. See, in the first round, what will happen? A will exchange its distance vector to B will exchange its distance vector to A, and similarly B will exchange its distance vector to C, and C will exchange its distance vector to B. So B old distance vector of B will get transmitted to C, not the new one. So old is still having infinity. That is why C will still be having infinity, because the new distance vector of B will be conveyed to C in a next exchange. So currently this is the scenario, which means that that after one exchange we will say that okay, now distance to A is 1, and C will say now distance to C is distance to A is still infinity, and this is after one exchange. So this is initial, right? And then after one exchange, this is the case. Now what will happen? Now again B will exchange its distance vector, so C will get to know okay, this is just 2 hop away, and now B will say that okay, I am just 1 hop away and everything is fine, right? This is after two exchanges, after I mean 2 rounds or 2 exchanges. Now again B will share its distance vector to C, and C will also share distance vector to B, and A will also share. So every node will share its distance vector to neighbors. So again these values will be 1 and 2 only. So these values are static now, 1 and 2, 1 and 2 everywhere, right? So after just 1 or 2 rounds this value is getting stable. So it was a good news. From here to here it was a good news, and this news got traveled very fast, which means this news just in 1 or 2 exchanges we got to know, or this B and C got to know okay, this is 1, this is 2, right? Just in 1 or 2 exchanges. So this news traveled fast, and this is a good news. But if there is a bad news, which means suppose this link was initially connected, this A B C was initially connected, and initially this was the case that B was thinking that okay, A is just 1 hop away, C was thinking A is just 2 hop away. I'm just writing distances to A. Now suppose this link get broken, which means this A is no more connected to B, but B and C are connected. Okay. Now after this link get broken, now after this B will exchange its distance vector to C only, not to A, because this link is not there. So, and C will exchange its distance vector to B. Now, on receiving the distance vector from C, B will think that A is 2 hop away from C, which means just 3 hop away from me, right? You're getting why I'm writing 3? Because when B will receive the distance vector from C, it will think that A is just 2 hop away from me, 2 hop away from C, then 3 hop away from me. And when C will receive the distance vector from B, it will still be thinking that A is just 2 hop away from me, right? Now, this is after one round. Now, in the next round, what will happen? B will share its distance vector to C, and then C will think that it's 3 hop away from B, then should be 4 hop away from me, and B will still be thinking that A is just 3 hop away from me, right? Because 2 hop away from C, then 3 hop away from me. Then after one more round, what will happen? B will exchange its distance vector to C, and C will exchange its distance vector to B. Then B will think that okay, A is 4 hop away from C, then it should be 5 hop away from me, and C will still be thinking it is 4, because 3 hop away from B, then 4 hop away from me. Now it will keep on happening, which means now you will be getting these values like 1, 3, 5, then 7 maybe, and here you will be getting 2, 4, 6 like this. See here. See, like in the bad news, you will be getting the values like 1, 1, 2, then 3, 2, like that. I mean, you will be counting till the infinity. Your infinity number could be anything. I mean, you can define the upper bound, maybe 15 or something. So it depends on the TTL, because if it is, let's suppose TTL value is 15, then if it is more than 15 or hop away, then it does not make any sense, because like we will say that anyway TTL will expire by that time, right? So you can say that infinity is just 15, but yes, whatever is your infinity, it is counting till the infinity. Once this link get broken, it is counting till the infinity. See, once this link get broken, it is counting till the infinity, because it is not getting any update from A, it is only getting update from C and B. So that's how it is working. And clearly this is a problem. See, I'm not saying, just listen carefully, I'm not saying that this is a I'm not saying that this is not working, which means like it is still working. Ultimately what I want from B, like I want here to be infinity, I want from C to be also infinity. Ultimately I want the distances to be infinity. So it is working. It's not like it's wrong, it's just like it's slow, right? It's not like it's wrong, it's just that it is slow. I hope you got it. So this count infinity problem is not as such a problem where I cannot even implement distance vector routing. Okay, it's just that it's slow. Its convergence is very slow. So that's all I want to say here. I hope you got it. But fortunately, there is a solution in some cases, and in some cases there is no solution. So let me tell you what is the solution. See, why there is a problem? Because whenever C is conveying this 2 to B, then B is thinking that there is some way that C knows and C can go to A via 2, right? But C is not telling to B that, see, I am already dependent on you, which means C is not saying that this 2 is because of you only. I mean, if I have to forward the packet, then I have to go to you, and then you will only forward. Like I got to know this 2 from you only. You have only told me that okay, A is one hop away, so that's why I have written this 2. Now C is telling this information to B, then B should not be relying on this information, which means she should not only tell that okay, the distance is 2, she should also tell that this distance is 2 because of you, which means like apart from this 2, she should also share that what is the next hop. If next hop is B only, so just not 2, it should just know the distance vector, it should also share the next hop, right? If next hop is B only, then we will understand that okay, if next hop is me only, then I should not be dependent on this value, because it is already dependent on me, then I should not depend on C. That's how we can solve this problem. But again, this problem is not solvable in all the cases. Basically, just the next hop is not necessary to know. You need to know all the hops in the between, and that's called the path vector. And path vector routing is basically just an extended form of distance vector routing, which is not in the syllabus. And path vector routing solve this problem completely, but this distance vector routing solve this problem in some of the cases where you just have 2 or 3 nodes. But if you have multiple nodes, then you need to actually share all the path. See, if you have multiple nodes, then you should not be saying that the next hop is you. you should be saying that what should be the whole path. Like you will get to know this problem in one of the question that we will be doing in the next video. But here I just want to convey that this distance vector routing has one problem, which is a count to infinity problem, but it's not actually a problem, which means I can still implement distance vector routing, but it's just a slow method. Okay. Second thing is that in some of the cases, if I share the hop, next hop, see in this case, in this particular case, if I share the next hop, which means if shares the next hop is B only, then B will never update this 1 to 3. We will say that, okay, I do not know. Basically, you are already dependent on me, then I should not be depending on you. Then we will immediately say this is infinity basically. Why? Because we will say that I have no way to reach to A because C is already dependent on me and there is no other information I have from A, so it will keep it to infinity. That's how we can solve this problem in this case. But in some of the cases we cannot solve this problem. Okay. So this problem is solvable in some of the cases. This problem is not solvable in some of the cases, and this is not actually a problem. Which means if the distance vector routing is not a wrong implementation, it's just that it's a slow implementation. Right? I hope you got it. So if you read this paragraph, then you can read it like whatever I explained, that is also written in this paragraph. Okay. And in the next video, we will be solving one gate question.